Transcription is the first step of gene expression. During this process, the DNA sequence of a gene is copied into RNA. There are different types of RNA. mRNA copies DNA's code carrying the genetic information to the ribosomes. tRNA transfers amino acids to the ribosomes where proteins are synthesized, and rRNA are sets of proteins that form the ribosomes.
DNA strands consist of deoxyribose sugar, two strands and CGA and T bases, while RNA contains ribose sugar, one strand, and CGA and U bases. DNA is required for making proteins, therefore changing the DNA code may cause a change in the process of amino acids, changing the way proteins interact with its shape and function.
The aim of translation is for the ribosome to read the messenger RNA and use the info to create proteins. mRNA encodes a polypeptide chain of amino acids. Transfer RNAs are molecular bridges that connect mRNA codons to the amino acid they encode. The first step in translation is for the ribosome. The next step is elongation, where the amino acid chains get longer. In elongation, the mRNA is read one codon at a time, and the amino acid matching each codon is added to the growing protein chain. Each time a new codon is exposed, a matching tRNA binds to the codon. The existing polypeptide is linked onto the amino acid of the tRNA via a chemical reaction. The mRNA shifted one codon over in the ribosomes. This process repeats many times as new codons are read and new amino acids are added to the chain. Termination is the last step in translation in which the finished polypeptide chain is released. It begins when a stop codon UAG, UAA, or UGA enters the ribosomes. This triggers a series of events that separate the chain from its tRNA and allow the tRNA to drift out of the ribosome. Or UGA enters the ribosomes, triggering a series of events that separate the chain from its tRNA and allow the tRNA to drift out of the ribosome.